So in the beginning of our study of the binomial expansion theorem, we really focused on finding specific coefficients of these expansions. One of the ways that these binomial expansion problems can be made a little bit more complicated is instead of asking you to find the coefficient, they'll give you the coefficient and ask you to find the parameter, to find the value of some unknown in the problem. And so I have an example of that right here. In this problem, you're being asked about an expansion right here, and this time they tell you that one of the terms is negative 1000x, and you're being asked to find the value of a, this parameter that's right here. So what I'd encourage you guys to do when you're thinking about these problems is they're effectively talking about the term that includes x. So approach this problem in such a way, right? How could I find an expression for the term of this that contains x? So remember that whenever we do binomial expansions, there's always a combinatorial coefficient, there's the first term raised to a power, and there's the second term raised to a power. So the question is, what exponents would I need to use here? If I wanted to wind up with an x, I would need to use an exponent of 1 here, and I need to use an exponent of 3 here. Remember, the reason that I know that this has to be a 3 is that these two things have to add up to be the power that we're raising the binomial to from the beginning. So what we're doing here is we're basically trying to find what the coefficient of x is, but we already know that. We already know it's negative 1000, so we're going to use this to figure out what a is. The other thing that I need to do here is I need to write in this combinatorial coefficient. I'm going to have a 4 up here because I'm raising to the 4th power, and a 1 here because that's one of the powers that I'm using here. I'm going to save us a little bit of time here. I hope you guys are already pretty good at figuring these combinatorial coefficients. This coefficient here is going to be 4. So I have 4 times 2x times a cubed. This gives me 8a cubed x. And now at this point, I can see that the coefficient of x is supposed to be 8a cubed. But they also told me that's supposed to be negative 1000, so I can just set those equal. 8a cubed equals negative 1000. Dividing through by the 8, you'll get a cubed is negative 125. And then finally, cube rooting both sides will give me that a is negative 5. And there it is. These problems are really not that much more difficult than our initial binomial expansion problems were. By the end of this, I'll have ramped the difficulty up just a little bit, but for the most part, this is really just about sort of this skill, and we've been using this for a long time now, right? This skill that when we're being asked to find a parameter or to solve for a value, what we need to do is we need to come up with an equation. We need to use the knowledge of the math that we have to come up with an equation so that we can solve that equation. And let's go on and look at the next example. All right, so here we've got another one of these. You'll notice that's a really big number. This thing's talking about negative 1.5 million. Please don't be scared by that number. When there's a number that large, it just means this is probably going to be a calculator problem. So if you've got your calculator nearby, great. If not, pause the video and get it. I would encourage you guys to try this one on your own. See how far you can get in it. So in the expansion of ax minus 3 to the 8th power, the coefficient of x to the 5th is negative 1,548,288, and you're being asked to find the value of the parameter a. Same deal as we did before. This problem is indicating to you that we are talking about the x to the 5th term. So we need to come back here and figure out what's the combinatorial coefficient, what power do I have to raise ax up to, and what power do I have to raise negative 3 up to in order for me to get x to the 5th. Hopefully it's pretty clear. This is going to need to be a 5th power. That means this has to be a 3rd power, so they can combine to give me that 8. And then the combinatorial coefficient has to be 8, 5. Okay. At this point, it's just a matter of solving these pieces and then setting it equal to this coefficient that we know about. Okay. So first, the combinatorial coefficient for 8, 5. This would be 8 factorial over 5 factorial, 3 factorial. That'll reduce to 8, 7, 6 over 3, 2. That'll drop those out. So it looks like we're getting 56 for this combinatorial coefficient. And then we have a to the 5th, x to the 5th, and we have negative 27. Okay. At this point, I need to multiply these. We sort of need to pull this all together. If I multiply these two things together, I get negative 1,512 a to the 5th, x to the 5th. And again, at this point, we can tell what the coefficient of x to the 5th is. This is the coefficient of x to the 5th. So at this point, we can write our equation. We now know that negative 1,512 a to the 5th has to equal this huge number. Okay. And at this point, this is sort of a straightforward little algebra question, right? I need to divide both sides by this negative 1,512. When I do that, the calculator tells me that this is going to be 1,024. Okay? And then from there, I just need to take a fifth root of both sides. Whether that fifth root is something that you can do mentally or whether you need to do a calculator is fine either way. We find out here that the fifth root of 1024 is 4, and that's our answer. The question had asked us to find the value of the parameter a so that this happens. So I hope you guys recognize in these problems that for as much as the wording of the problem is a little bit different, the problem at its core isn't really that different or difficult. The idea here is that we need to recognize that they're talking about the coefficient of x to the fifth, so we're going to get an expression for the coefficient of x to the fifth. We'll set that equal to the value that we're given, and then at that point we just solve for the value of the parameter that we're looking for. So now let's take a look at one more example. So here's our next example. I hope that something you notice right away about this problem is that it involves two parameters. You're being asked to find the value of a and b, and this is something we've seen quite a few times now. If you are ever asked to find two parameters, what does that almost always lead to? Hopefully the thing that you just said either out loud or in your mind is a system of equations. If they want me to find two things, I'm going to need two equations, right? Well, fortunately in this problem, it looks like they gave us two different coefficients. So your strategy here should be get one equation for the fifth power coefficient, get one expression for the fourth power coefficient, and then use those two equations together to find the values of a and b. So go ahead and pause the video now and at least set up what the expressions are going to be for the two coefficients. Okay? So here's what I'm seeing. I'm going to have a coefficient, and then I'm going to need to have ax raised to the fifth power for me to get that fifth power. That means b is going to have to be raised to the first power because this whole thing is sixth power. That means this combinatorial coefficient is 6, 1. And I can actually do that pretty easily, right? This is 6a to the fifth, x to the fifth, b. Written a different way, this means 6a to the fifth b, x to the fifth. And the reason I like writing it that way is it lets me see really, really clearly this is the coefficient of x to the fifth. Okay? So that means that 6a to the fifth b has to equal negative 30. So hopefully you got that as one of your expressions. If you haven't done the other one on your own, again, pause the video, give yourself a chance to try this. For the other one, I'm going to be looking at x to the fourth term. So I'm going to have combinatorial coefficient, ax to the fourth, and that means that b this time is going to be squared. The combinatorial coefficient is 6, again 6 because of that, and then you've got a 4 for the bottom of the combinatorial coefficient. If we figure that coefficient out real quick, 6 factorial over 4 factorial 2 factorial, that's going to give me 6 times 5 over 2. So let's see here, that'll be 15. So 15a to the fourth, x to the fourth, b squared. Or again, kind of like I did on the other one, 15a to the fourth, b squared, x to the fourth. And again, that kind of seems like a mess. It's like alphabet soup here. But this thing here, we can say that 15a to the fourth, b squared has to equal 375. And here we are. I have two equations with two unknowns. I should be able to work through and use these two pieces of information together to solve for these parameters, to find out what a and b are. I suppose the real question, though, is how? Like, how am I going to go about solving this system of equations? It seems like a method that we like to use a lot is this idea of substitution, right? Which of these variables, a or b in either equations, would be the easiest to solve for? Hopefully you recognize that this b over here is probably the easiest one to get alone. So if I were to just take this 6a to the fifth and divide it over this way, we'd find that b is negative 5 over a to the fifth power. Now that I have that relationship, I can take it and I can put it into my other equation, to my other relationship. I'll have 15a to the fourth times negative 5 over a to the fifth squared equals 375. Okay, and on the one hand, no, this isn't super simple, but this also isn't terribly complicated. We can do this. 15a to the fourth times 25 over a to the 10th equals 375. When I multiply this 15 together with this 25, that actually winds up being 375. So this is 375 over a to the 6th equals 375. Let's see here. If I divide this 375 over and multiply the a to the 6th over, I'm going to end up getting 1 equals a to the 6th. Taking a 6th root of both sides, we get that it looks like a could be positive 1 or it could be negative 1. Now that I've found these values, I can plug them back in over here and sort of see what I wind up with, right? If I take b is negative 5 over plus or minus 1 to the 5th power, plus or minus 1 to the 5th power is still plus or minus 1. This gives me b is negative 5 over plus or minus 1, and so this is going to end up giving me minus or plus 5. Oops, that was supposed to be a 5. Minus or plus 5. And those are our solutions. These are the values that allow us to get those things back to the beginning. By the way, if this bit at the end was confusing for you guys in terms of plugging in a plus or minus, feel free to plug in the positive one first and find out what the answer is. You'll find it's negative 5. Then you can plug in negative 1 and find out that the answer is positive 5. Hope this all made sense. If you've got any questions, make sure that you let me know. Ask them.